Okay. Let us consider tossing of coins. Now, if you toss a coin once, you will get heads or tails. If you toss a coin once, you will get either heads or tails. Now, if you toss a coin twice, the possibilities could be heads heads, heads tails, tails heads, or tails tails. 4 possibilities. So, what we are considering is first toss, 2 outcomes. For each of these outcomes, in the second toss, you have 2 more outcomes. So combination is 4 outcomes. Similarly, if you toss a coin thrice, total number of outcomes are going to be, or in general, if you toss a coin n times, or if n coins are tossed once, both are the same, 2 power n outcomes. Let us take a question. A coin is tossed 5 times. In how many possible outcomes we get exactly 3 tails, at least 3 tails, at most 3 tails. Try this problem. Okay. Coin is tossed 5 times. How many possible outcomes? We get exactly 3 tails. Now, those 3 tails can be, let us consider one possibility. 3 tails, 1 heads, 2 heads, right? 3 tails, 2 heads. Now, in how many ways is this possible? It is nothing but number of ways in which you can arrange. Okay. Now, in how many ways you can arrange this? Assuming these are like A, B, C, D, E, all are different, then it is possible in 5 factorial ways. But then this arrangement, wherein there are 3 T's and 2 heads, these are similar. So similarity in case of similarity we can consider it like this, or in short we can say it is 5C3. Okay, I'll explain this in more detail when we consider all possibilities of arrangements. Okay, now here at least 3 tails. At least 3 tails is, you can get 3 tails or 4 tails or 5 tails. Now 3 tails we have already done, which is 5C3. 4 tails is 5C4. Same logic. 5 tails is 5C5, or just one outcome. If this is possible, or this is possible, or this is possible. That is for second. Coming to third, at most 3 tails. At most tail should be less than or equal to 3 at most, which means 0 tails, 1 tails, 2 tails, 3 tails, which is 5C0, 5C1, 5C2, 5C3. Throwing of dice. Now, in case of throwing of dice, let us say a dice is thrown once. If a dice is thrown once, what are the different outcomes possible? 6 outcomes. Six outcomes. If a dice is thrown twice, then what are the different outcomes possible? For the first dice, 6 outcomes. For each of those outcomes, for the second dice, there are 6 outcomes. Similarly, if a dice is thrown n times or n dice are thrown once, then you will get 6 power n outcomes. Let us take a question. A dice is thrown thrice. In how many possible outcomes we get sum of 16, sum of at least 16, sum of at most 16. Try this problem. Okay. Now sum of 16. How will you get a sum of 16? Let us consider you tossing a coin, throwing a dice thrice. So let us consider the maximum possibility for the other two, which leaves us with 4 as minimum option. Right? This is one possibility. Now in how many ways this is possible? It is nothing but the arrangement. Right? Had they been different, it would have been 3 factorial, but because 2 6's are there, 2 factorial. How else this is possible? It is possible like this as well. In this case as well, it is 3 factorial by 2 factorial. Any other possibility? There is no other possibility. 2 5s 1 6, 2 4, 2 6s 1 4. They are the only two possibilities, right? I'm saying 2 6s and 1 4. So what I mean to say is the 6 can be here as well. 6 4 6 is also possibility. That is taken care in these arrangements, right? So write down only possibilities, then consider the arrangements, right? So that is the correct logic. Write down combination, then arrangements. Right? Okay. Next. So 3 factorial 2 factorial 3, 3 factorial 2 factorial 3, total 6 ways. It is possible. Coming to sum of at least 16. For sum of at least 16, sum of 16 is a possibility, or sum 17, or sum 18. For sum 18, it is 6 6 6, right? Combination. So in how many ways you can consider? 3 factorial by 3 factorial, right? Or just one way, right? Now coming to this 17, so you can consider it as 5 6 6, 2 6s and 1 5. In how many ways it is possible? 3 factorial by 2 factorial, that is 3. So 6 plus 3 plus 1, 10. So answer here, it is 6, it is 10. Sum of at most 16. Sum of at most 16, that is, what is the minimum sum possible? 1 1 1. Sum of 3 to 16. So sum 3, 4, 5, 6, 7, 8, 9, 10. There are so many possibilities, right? Think of what are the total number of possibilities. You are throwing a dice thrice. That is 6 power 3 outcomes. This is total, right? From that, if you subtract favorable outcomes, favorable number of outcomes for sum 17, sum 18. So if you subtract these two, then we get the total number of outcomes. That is 216 minus 3, sum 17 minus 1, or in other words 212 outcomes. So there is heavy possibility to get a sum of at most 16. By the way, in tossing of coins and throwing of dice, I touched upon something called as arrangement. So let us discuss that in detail. Arrangements. Okay, getting back to that. Five gents and 4 ladies. 5 gents and 4 ladies. Are in a party. In how many ways they can be seated in a row. If nothing is mentioned, you assume that there are 5 plus 4, that is ample number of chairs. Try this problem. The answer should be pretty easy. 5 gents, 4 ladies and 9 chairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, regarding 5 gents and 4 ladies, preference is not given. That means anybody can sit anywhere. So, in the first chair, any one of these 9 people can be seated. In how many ways? 9 ways. For each of those possibilities, in the second chair, any one of the remaining 8 people can be seated in 8 ways. So, put together, when I said for each, and for each of those 72 possibilities, in the third chair, any one of the remaining 7 people can be seated. Therefore, the total number of possibilities is 9 into 8 into 7. Similarly, into 6, into 5, into 4, into 3, into 2, into 1. Right? This we call it as factorial. 9 factorial ways. Okay, let us take another question. Now try this problem. Okay, one simple understanding is you remove 2 chairs. Then you can ask me one intelligent question: why only the last 2 chairs? Why not in between or in the beginning? Very simple. First chair can be occupied by any of the 9 people. For each of those possibilities, second chair can be occupied by any of the remaining 8. So going by that logic, you remove any 2 chairs, that's okay, but you will be left with these possibilities only. This is the answer. This is the answer. But if you wish to generalize this, how can you do that? One method is you select 7 out of 9 people. Then you will have 7 people, 7 chairs arrangement. Now this is possible in 9C7 ways, and this is possible in 7 factorial ways. So that is 9C7 into 7 factorial. This is generalization, right? This is also termed as 9P7. So NPR, it is equal to NCR into R factorial. Okay. Thirteen contestants are participating in an event consisting first, second and third prizes. In how many ways prizes can be given away? In how many ways prizes can be given away? Try this problem. Okay. Now, whenever you're talking about something going to the other, you decide those two parties. First part is contestants, second part is prizes. Right? And decide the capacity. For example, prizes, capacity. What is the capacity of each prize? It can go to only one person. Here no other information is given, so we assume that there is no tie. So there is no equal honors. So capacity of one prize is just 1. It can go to only one person. So 1 into, how many prizes are there? 3 prizes. So total capacity is 3. In terms of contestants, for contestants, a contestant can receive only one prize if there are first, second and third prize. He is not eligible for second prize if he is already receiving third prize. Right? So 1 into 13. This problem is easier because you are given straight away first, second, third. I'll also discuss some other problems wherein we have to go by this method and then the problem will become very, very easy. Right? Now, as soon as you decide the capacities, right, treat the problem with respect to where the capacity is less. Where the capacity is less. Treat the problem with respect to where the capacity is less. So capacity is less with respect to whom? With respect to prizes. With respect to prizes. Right? So first prize, second prize, third prize. First, second, third prize. So first prize can be given away to any one of the 13 contestants in 13 ways. For each of those outcomes, for each of those possibilities, second prize can be given away in 12 ways. For each of those 13 into 12 outcomes, third prize can be given away in 11 ways. There is one more way in which you can do This method can be done only when the individual capacity is 1. Right? That is the previous one. 13C3 you select. As soon as you select, it can be first, second, third can be interchanged in 3 factorial ways, or 13P3. Both should give the same answer. Let us consider another problem. Thirteen contestants are participating in an event. Are participating in 3 events. And for each event, a prize is allotted. In how many ways prizes can be given away? Try this problem. Okay. Let us consider prizes. Here again, prize can be given away. Each prize can be given away to only one person. Each prize can be given away to only one person. So there are 3 prizes. Whereas each contestant can win all 3 prizes, right? First event prize he or she can win. Second event prize he or she can win. Third event prize also he or she can win. So individual capacity is 3. Anyway, even if you have not done this logic, for this problem you would have went with honors. In the sense, if we consider first prize, second prize, third prize. First prize can be given away to any one of the 13 contestants in 13 ways. For each of those possibilities, second prize can be given away. It is not second prize, it is second event prize. Right? This is first event prize. Second event prize can be given away to any of the 13 contestants, right? A contestant who received first event prize is also eligible for receiving second event prize. Third event prize can be given away to any of the 13 contestants in 13 ways. So the combination in which you can do total number of possibilities is 13 power 3. 13 power 3. Let us take a small break. After break we will